Hello and welcome to this iSystem video about continuous integration within an embedded software development context. We will take a look at what this is, its infrastructure, and benefits. Automated build and tests have become an integral part of modern software development. Continuous integration, or CI for short, is also becoming more and more popular in the embedded field. Every time a developer integrates a code change into the version control system, a CI cycle is triggered automatically. The CI infrastructure fetches the source code from the repository and runs it through build and test stages. After each cycle, a qualified statement is available on how the change affects the status and the quality of the software. If all stages pass with a positive result, the software is ready to be delivered. If any of the stages fail, like for example the build breaks or tests are failing, developers get prompt feedback and are thus able to react quickly in order to fix the issue. After the rework is done and committed to the repository, another CI cycle is triggered automatically. How does CI improve your workflow? CI allows you to keep the quality of software on a high level. It provides developers with instant feedback on whether the code change is okay and doesn't break the code base. Verification and tests are performed in an automated way, so engineers can focus on software development. This results in an overall speed up of the development process. It enables finding bugs faster and stabilizing new software sooner. It also saves costs and increases the overall application quality. To achieve this, new functionalities and tests are constantly created and contributed to the repository. As mentioned before, a CI server coordinates the necessary automation steps. This is performed using the concept of pipelines. Pipelines are a series of steps that need to be executed for continuous integration. A typical pipeline consists of several steps. First, the source code is updated. Then static code analysis is performed, followed by a build. Unit, integration, and system tests are executed next, with delivery being the final step. This way, the code is thoroughly tested and stable, and the software is ready to be delivered. To perform on-target tests, your hardware needs to be integrated into the pipeline. For this purpose, iSystem provides the iSystem.Connect Software Development Kit, or SDK for short. It's a free and public API for remote control of the iSystem hardware and software within such a process. You can use the iSystem.Connect SDK to integrate debuggers into your test process. The SDK is easy to learn, and most of the use cases are covered in the provided examples. It supports Python, Java, C#, and MATLAB. You can quickly get up to speed and write tests that execute on the hardware. What role do iSystem products play in CI? Having full control over the target hardware, Blue Boxes are a powerful tool for on-target testing. Integrate WinIDEA in combination with the iSystem.Connect SDK in your CI pipeline. It provides you with download and run control, also in conjunction with third-party testing tools, complex non-intrusive testing and verification, and fault injection. You may wonder, how is my code change affecting the performance of the ECU? Or what impact does a module have on the runtime behavior of the system? The answer lies in the timing behavior of the ECU. The complexity of applications is rising, and controllers are getting maxed out to their limits. Using trace technology allows you to observe timing behavior and code coverage. It's non-intrusive, without instrumentation or modification of the source code. Continuous integration infrastructure. In a team consisting of several developers and testers, changes are sent to a code repository. A CI server, like Jenkins or GitHub, can run locally or in a cloud. It controls a number of CI nodes with different roles. It detects a contribution to the code repository and tasks a build node to build the application. If this succeeds, It then engages test nodes, which will generate the test reports. To test the real behavior of a software, tests often need to be performed on the hardware itself. A test rack equipped with hardware debuggers connected to target hardware comes in handy here. The concept of hardware test racks brings several benefits. Equipped with USB and Ethernet interfaces, our blue boxes can be used to implement flexible access scenarios. Embedded targets can be accessed through debuggers 24/7 from anywhere in the world. Engineers can use the targets for development and manual testing purposes across different projects. Smart parallelization of on-target tests using multiple targets allows faster turnaround times and quicker feedback for developers. Complex hardware setups are located in a controlled environment. Sensitive hardware no longer needs to be placed on the engineer's desk. By understanding how continuous integration is able to contribute to the success of your embedded projects, we can now get to work. We know that establishing a smooth CI process can be a complex task. Luckily, we have an experienced team of consultants who are happy to help you get there quickly. Thank you for watching and see you soon!